Good morning. The problem with me today is that I don't speak Ukrainian at all. And I can just say spasiba, and even then I think it is not the right pronunciation, so I'm really sorry for that. So I hope my English will be understandable. You just let me know if I speak too fast, right? I know I can speak fast, and on top of that it will come with my French accent, so it is not at all understandable. But okay, you just let me know. If everyone has a problem in my understanding, so just let me know, interrupt me, and I will try to get someone to answer your question or translate what I just said. Is that fine?
Yes.
Okay, thank you. So as said, my name is Philippe Trauman, and I'm the Sales Director for High Performance Computing and part of the Performance Optimized Data Center. So I will talk a lot about servers, offerings, and how HP differentiates today. So I hope it will be an interesting talk. My interest is having a dialogue, right? And have you ask as many questions as you want. Don't hesitate to interrupt me. Some things might not be self-explainable, so just ask questions. I love to be interrupted. Someone will translate, right? So what is our goal at HP? At HP currently, we know that there are many types of demands, okay? And when we talk to customers, the demands are not at all the same. So I just would like to check with the audience who is coming from the academic sector, academic research, almost half of the audience. Coming from the partners, whomever, so all the partners. Partners, and the industry. Okay, so that might be one of the issues that we have to face, because the more we go, the more we see that high-performance computing is moving from a pure academic play to a real industry play. Okay, and that's what we are seeing in the trends that we have to face at HP. So obviously we see a lot on the left side here, a lot of CAE manufacturing oriented. So that's really for the automotive, aerospace, electronic design. So all the Airbuses, car manufacturers, are the manufacturers of chips, ST Micro, all of these people are using these resources. Then you have the R&D, pure R&D, for life science and pharmaceuticals. That's a very big domain with DNA sequencing, drug design, simulations. So this is one of the areas where we see a lot of growth. Now this one is probably the biggest user of HPC, and this is oil and gas. Oil and gas are having the biggest systems of the industry. And why is that? Because the cost of exploring oil fields has become so huge that the relative cost of simulation, so doing seismic or reservoir simulation, has become the biggest worry of those companies. So if I look at companies like Aramco, like Total, like Shell, like BP, all these guys are running thousands, if not tens of thousands of servers to run their seismic applications or their reservoir simulations. So this is a huge domain for us, especially because they are really number crunching all the data. Another domain is the visualization and media. And we have a lot of activities there, mostly with partners. So we know that we work with NVIDIA. I know that there was an NVIDIA workshop yesterday. And I guess, is there an NVIDIA presentation today again? Yes, okay, so there will be an NVIDIA presentation. So we work a lot with NVIDIA on all those graphic, rendering, and visualization issues. And finally, one of the most developing domains is defense and finance. Finance, that's for banking. So that's really for credit simulation, Monte Carlo simulations, all these domains, and that's growing quite fast. One of the biggest domains is obviously the high-frequency trading, and that's a very specific high-performance domain. It is in the middle of HPC, big data, and extremely low latency handling. But the biggest, one of the biggest one is defense. Defense has huge requirements, and that's in terms of, well, secret agencies, dark agencies, which are doing face recognition, which are doing data encryption and decryption, which are doing all these activities. So this is for us one of the largest domains, and if I can just tell you the size, the magnitude at which we are working, one of our customers in the defense area, he has one application, only one application that requires half of a football field of racks. Can you imagine? One application. Half a football field of racks. Okay, and that's not the CIA, right? So it's another agency. Okay, so that's just to give you the kind of magnitude of the problems which we have to address with HPC today. So now let's move on to what HP can provide there. What we are very proud of at HP is that we not only have the products, but we also made sure that we have the capacity to deliver and run. So we want to make sure that alongside with our products, we are able to manufacture those systems, test them, integrate them, and deliver to you pre-integrated, pre-tested, so that you don't have to worry about the fact that the cluster is delivered without all the software tools, software optimizations, and whatever the ISV. Is that clear? ISV, so the independent software vendor? Yes? Okay, so everyone knows the ISV. When I talk of ISV, that means independent software vendors. So we do all the pre-integration, and we deliver these systems to our customers pre-integrated and pre-tested. And you can be sure that this is appreciated by our customers, because their work is not to run IT. Their work is to develop products. Okay? What they want is a system that runs. Now, this has been a trend that we have been seeing. If I start at the lower end, we obviously are able to build these clusters. Okay, so we have purpose-built servers, we have the software tools, and we have the cluster management utility that allows us to monitor and provision the system. So that's the build to order clusters. After that, we integrate the interconnects. Okay, so we work with whomever provides the best technologies. For the time being, that's only Mellanox and Intel, which is coming back. Okay, so Mellanox, we integrate the latest clusters, and for us, we delivered the first support for Blades on InfiniBand, and also the top 500 system with, the first system was with FDR, with HP. Okay, after that, we integrate the accelerators, whether they come from NVIDIA or whether they come from Intel, and I will show you how we integrate those accelerators and how we do some additional work to make sure that your application will benefit of those accelerators. After that, we have the infrastructure. So that means that if you need to host your system in a specific environment, because it requires, I don't know, an external data center, we have the pods offering, okay, the performance optimized data center, I will mention about that. And we also have extremely performing water-cooled systems. And this is also something that I will touch upon. And finally, and I will also disclose to you some details, we are completely and radically changing the way that we look at our HPC customers by providing low-power solutions or extremely dense solutions. And I will come back to that. Maybe some of you have heard about the Moonshot project or about the Apollo project. And I will have some words about it. But now let's move to our market share. At HP today, IDC recognizes that HP for the timing is the #1 company on the planet to deliver HPC. We are in front of IBM, we are in front of all the usual traditional players that you may see, T-Platforms, SGI, Cray, Google, name it. We are in front of all those guys. We deliver, and that's on the last top 500. On the last top 500, HP has delivered 190 systems out of the top 500. Is top 500 known to all of you? Yes? You know top 500? Okay. So we have delivered in the last release 190 systems. So coming in front of IBM by far, because IBM has only 160 systems. Okay? And you see all the others which are far behind. So what I was saying is that at HP, we have the ability to deliver many systems. It is an industrial provision, so we know how to deliver systems and we have the capacity to do so. Any questions or comments, by the way? No, fine, let's move on. So let's now come to some of the products, and I will not focus on all the products, I will only focus on a few products that are available. Some of you might be familiar with our blades chassis, which are very well known by the community. And this is a workhorse at HP, and we continue to develop this chassis, and we just have announced the availability of Ivy Bridge on this chassis and on the. So this is the workhorse for many customers. However, this does not support accelerators. So this means that we will have to move elsewhere if we want to support accelerators. We then have the very traditional pizza box type, which is the PL9, okay, which probably many of you know. This is our HPC, or so-called at HP hyperscale dedicated line, which is the SL line. And I will comment a little bit on that, because there's quite a bit of innovation going on into this line, and this is a dedicated HPC solution. Okay? And finally, I already mentioned about extremely low power computing solution, and this is our Moonshot product line, and I will comment a little bit as how this could be used for a certain number of your HPC users or HPC applications. As I'm talking to an academic crowd, I just would encourage you as academic crowds to consider the power usage of all the solutions that you are putting in. So we know that accelerators provide a good jump in terms of flop per watt efficiency. But with this solution, we are getting to a factor of 1 to 10 as opposed to a traditional x86 server. 1 to 10, so that means 10 times less power consumption. So if you have users that are constrained by power, then this might be the right solution. We will come back on that a little bit later. So let's first start by the storage product, which is the SL4500. So what it is a 4U box in which you can have servers and storage. So that means that I'm calling that a storver, a storage server. And that's pretty simple to understand. You put as many disks and you put as a front-end servers. Okay? And that's very low cost, very cheap, very efficient. So it is the best Hadoop TerraSort for you that are familiar with Hadoop. It is the best Hadoop TerraSort result that can be obtained on the planet currently. What it is, we have 3 versions, 3 flavors of that. The first one is a 1 compute node with 16 drives, SAS, SATA, or SSD. The second one is a 2-node configuration with up to 25 disks per server. So that means that we're going to have 2 servers, 50 disks, but shared into 2 parts. One server, 25 disks, one server, 25 disks. And we have the same for the 3 node with 15 disks each. Okay, so that's really used by all our customers that have tremendous data workloads needs. And if you look at this figure, if you look at the bottom, we can have as much as 27 compute nodes per rack. We can have up to 540 drives per rack and 500,000 IOPS, for those of you who are familiar with the IO per second, and up to 2.2 petabytes for a single rack. So this is pretty significant, and on top of that, this product is cheap. If you compare it to anything else on the market, it is cheap. Okay? So if you have needs for big data, for any kind of these workloads, don't hesitate to contact HP. That's one of our best-selling products currently for HPC usage. Sorry. So let's now move on to the workhorse at HP on SL, so specialized products for HPC. So this is, on the left side, the chassis. The chassis is a 4U box which comes in a standard rack and has basically 8 slots. It is dense, it is efficient, it is serviceable, it is a shared infrastructure. So you do not have anything like unique power supplies, everything is centralized. So everything is shared. Network, power, whatever, management layers, everything is shared in this box. And in this box you have 8 slots. Okay? And what we can do is we can either provide you with a half-width 1U server, that's HPC optimized, and you can put 8 of them in a single chassis. Okay? The second version is a half-width 2U box in which you can put as much as 3 accelerators. So that means that in a single chassis like that, you would be able to put 4 of those for a total of 12 accelerators. Some customers have huge requests for acceleration, so we have created the last one, which is the SL270. And this one is 4U high, but supports up to 8 accelerators, Xeon Phi or NVIDIA GPUs, NVIDIA Tesla. Okay? So that's really something which is groundbreaking if you want to look after some large users of accelerator technologies. We do have very large successes. If you look at oil and gas, all those guys can benefit, especially with the K10, which is the NVIDIA specific product developed for oil and gas. We have customers that are using thousands of them in the oil and gas sector. So this is the machine that we are selling most to our HPC customers. So it is a 4U chassis. It is a standard 19-inch rack. If we go to the multi-node and shared infrastructure, it is shared power and fans, so nothing specific to the nodes, everything is shared. We have redundant PSUs. We have 94% efficiency PSUs, so power supplies. And that's really very good for this type of machine. Now, what we also will do is look at the benefits of implementing the new technologies. So we now are about to announce the port of the Ivy Bridge processor on this platform. It has been released, so it is now available. So Intel Ivy Bridge is now available. We also support the 1866 megahertz memory on this machine. And we also have a smart array controller for all the disks that are going to be on this system. Is that sufficiently clear? Do you understand the logic which is behind? That everything can be connected obviously on InfiniBand, and we have all the necessary support for InfiniBand. So there's nothing that we cannot do with this machine. And again, our biggest customers on the planet are using this system. So these are the servers in detail. So you see here that it is the 1U version. All of them have, by the way, our I/O management features. And you see the various type of CPUs that are served. And again, we now have Ivy Bridge available on all these servers. Now let's come to the next wave of change. And this is HP Moonshot. And I just want to share with you some figures that our customers have observed. The first one is that if you look at the density of these systems, we have a ratio of 8:1 on the density. So if I look at one machine like this is a little bit more than 4U. The number of servers, and these are the servers, cartridges, that you can put into one of these enclosures is 45. 45 servers into this enclosure. Some of these cartridges have 4 servers on each cartridge. 4 servers per cartridge. So that means that suddenly you move to 180 servers in a single enclosure. And you can put 10 of them in a single rack. So that means that suddenly you have 1,800 servers in a single rack. What do we do with 1,800 servers in a rack? That's a lot. No? The amazing thing is that it is manageable. We have all the management tools that allow you to run that. On top of that, if you look at that, we spare 90% of the energy because we are using CPUs or systems that are extremely low consumption. So what you see for HPC is that it's going to change radically the way that you look at HPC. For HPC today, all of you are saying, I have an x86, I have a GPU or a Xeon Phi, and I'm going to adapt my application to run it on this infrastructure. What this allows you suddenly is to have a software-defined cartridge. So this is our promise, and we say HP will provide you the hardware that fits to your application. So you reverse completely the problem. Suddenly we provide you the right hardware architecture for your software. And this works very well in this environment. So we have plenty of examples, and I will come back to this. So for the time being, so that's a design of that system, a high-level design. Again, we have here the switching side in the middle, and you have all the cartridges which are there, the 45 cartridges, and we support a variety of things. So we can have compute, we can have storage, we can have x86, we can have ARM, we can have accelerators, we can have plenty of various things. It does not need to be one single type of cartridge in this chassis. It can be mixed and match. So you can have a certain type of cartridge on the 10 first, you can have storage on another 5, you can have another type of cartridge on another 20. So this is mix and match, and everything is serviceable as it is. So I hope that I give you the sense that this is radically changing the way that you can think of your HPC solutions. You do not think only, I'm bound by the x86, I'm bound by the Xeon Phi, or I'm bound by the NVIDIA. What I can do now is that if I have a specific application where I know I will benefit of a given architecture, HP can provide it to you, and we will see that a little bit later. So this is the rear side of Moonshot. It is shared infrastructure for everything. So we have a single management tool that will be able to manage and monitor all the cartridges which are inside this architecture. And this is also an illustration that we have a very, very flexible networking topology. So we have 3 layers of networking, but basically this networking is on the motherboard only copper. There's no logic. So we can provide at a high level any type of networking topology that you want, because we have the necessary infrastructure, so we can implement whatever we want, right, on the networking side. So that's really handy for those of you who have specific requirements on the networking topology side. So this is a typical cartridge, and that is based on Intel. So that's an Intel Atom cartridge, which is provided. So that's available today. If you want to order that today, our first customers are using that, mostly for very simple static web hosting, not HPC for the timing. But this is very traditional, and rather than virtualizing, going to a hypervisor, some customers say, hey, it costs too much to run my hypervisor. What I'm going to do is have dedicated server for my web hosting. And that's very simple. I mean, it goes without logic. You don't have a complexity of running your infrastructure. So that is one layer less. You do not need to look at the hypervisor anymore. So that's pretty nice. And you see the variety of OSs that we support. So we support Ubuntu, Red Hat, SUSE. On some of them we will support Windows, right? So that's also something which is going on. So this is just an illustration of the variety of workloads that could be served by such an infrastructure. And we will have solutions for all these type of workloads. So what is in green here, if you look at the green parts, which are here, we can serve that today. We are announcing a set of new cartridges here in 2013, where all the blue type of applications will be servable. So this is now available with specific cartridges. So we can do, you see the type of workloads that we can serve. If you are a banker, we can do Monte Carlo simulation, exchange jobs. If you do drugs, discovery, or that kind of thing, and life science. If you are in energy, so that's oil and gas, we will have a specific cartridge. The beauty about that is that HP delivers cartridges that we think are useful. But if you think you have a need, we can develop the cartridge for you. The development cycles and the number of units is very low. So that means that we can guarantee that we can deliver a cartridge that is specific to your needs in 3 months and for a very limited budget. So we are doing that already for several customers, including oil and gas customers. So we deliver now customer-defined servers. Isn't that amazing? This is something which is, again, a radical change in looking at your environment. If you are an industrial and know that you are running one main application, it just makes sense, because it will save you so much power, it will save you so much burden on running that application on a traditional infrastructure. So that's the type of thing that we think is going to take over. So I'm not saying that everyone will benefit. For the time being, it is with rather simple applications or trivial requirements. But again, very soon we are going to see a Haswell version of that cartridge. And Haswell is perfect for HPC. Well, Haswell low power will come out on this cartridge and can be used. So 45 Haswell cartridges on a single box. Can you imagine that? I mean, that's amazing. And the costs obviously are pretty significantly lower than the traditional infrastructure. Any questions, comments? So I'm enthusiastic about Moonshot because I really think that this is, it changes the paradigm. It changes the way that you can look at HPC, yet again, because it is something that is now driven by the software. So you think of your software architecture, and we provide you the infrastructure, the hardware that serves this application at the best, and for very limited power usage. So we are developing all those cartridges as we see. So we have announced 5 new cartridges, and very soon they are going to have another set of 6 cartridges. All of them being developed with our partners, whether it be Intel, whether it be ARM, whether it be NVIDIA. So we're going to have graphic cards, we're going to have digital signal processing, we are going to have encryption, decryption, all those type of workloads will be available. Sorry, do I speak too fast now? Still okay? Okay, thank you. So our partners are multiple. For Moonshot, it is not a simple thing. So we must work with a lot of partners to make sure that they are in this game of adapting their software or taking our hardware to run their software. So we have a lot of partners here, including ISV, obviously, but obviously hardware vendors are also there. What we can do for you is also to use these services. So we have what we call the Discovery Lab, and this is a very simple mechanism. If you think you want to test that environment or do a proof of concept, we can host you. So that means that you do that either in our labs or we do that remotely. You come with your problem and we help you demonstrate the value of this infrastructure. So this is something which is very straightforward. We deliver many of those Discovery Lab sessions, and this is something that you just contact HP, and we put you in contact with the HP Discovery Lab, which is in Europe. Okay, and this is very simple and straightforward. Okay, no cost, and we guarantee that you will be helped and supported by this team. So that's very simple to get something. Now let's move to the pods, or performance optimized data center. So this is something which we are selling mostly to countries which have issues with data centers. Okay? So whenever the data center is too old, too difficult to renovate, or whether you have to build a new data center, this is a perfect solution. Because this is very simply said, a data center in a box. It is a containerized solution. What we do is that we build the container, we take it to our factory after that, and we pre-integrate your IT. Whether it be HP or any other vendor, it does not matter. After that, we put it on a truck, deliver it to your site, crane it, put it on your ground, and normally, if everything, we have support teams which are able to do the service around that. The last example which I have, this is being used by one of our very large customers, whose name is Airbus. Probably all of you are familiar with Airbus. So Airbus is having all their HPC systems in pods. Okay, now we come back on that a little bit later. That's just to explain you that they did not want to build a data center, and they are using this as a support for pods. So I know that there are projects in Ukraine currently. We just have recently sold a very large project to a neighboring country, in Kazakhstan. That's simply to avoid the cost is so much to build an infrastructure, a data center, that it's more simple to bring in those solutions. So we have various models of pods, obviously. So we have either pods that are valid for performance, HPC with SL and blades, and that's also being used by service providers. Or we have the traditional pods that are being used. But again, I will come back on different models, just to let you know about the philosophy. The philosophy is to make sure that you receive from HP something which is equivalent to a data center. And we can have tier 2 or even tier 3 data center certification for these pods. This is also part of the data center complexities, is that the more we go, the more we see that we have requirements to cool racks which are extremely dense. So I'm not talking about Apollo, I'm talking about normal racks. This is the solution that we are using, which are side doors, which are liquid cooled. And that allows you to cool down up to 50 kilowatts per rack. Okay? And that's something that we provide, and that's an HP design that we are providing. So many of our customers are using this system for their cooling solutions in the data center. It is scalable, it is very simple to put in place. Now, I've covered products. So we've seen the storage products, we've seen the server products, we've seen the low power computing products, and we've seen the pods. All of that would be nothing if we did not have the capability to integrate with partners. So what we do, I was starting my talk by saying that we deliver many systems. I just asking you, how many HPC systems did HP deliver in EMEA this year? How many? Just have a guess. Tell me, how many systems could we have delivered? 50, 100, 200, 1,000? The reality is that we have delivered 300 systems this year. Okay, and we are only in October. So 300 systems just requires that you have a production engine. You need to be reliable. You need to have the factory capability to integrate, because each and every system requires hardware, software, tuning, InfiniBand, file system. All those components need to be put together. So you cannot produce 350 systems without a proper engineering capability at the fabrication level. So this is something where we are very proud to say that we have put in place all the components that are necessary to put everything in place for you. So we provide the accelerators, we provide the InfiniBand, we provide the monitoring tools, and we provide the hardware, obviously. And we are able to put that in relationship with the fabrication at our labs, right? So that's really something that makes us unique. We are massive producers of HPC systems. So it is reliable, it is safe, and we know how to deliver. So this is on the Mellanox side. Obviously, we implement the latest Mellanox side. In many cases, we co-develop with Mellanox because we have so many systems. We are able to implement those systems with them and co-design specific components. So whether it be for our SL line or for our blades, we have specific developments which are being done. We obviously integrate also the accelerator solutions from all the vendors. So we have the latest Tesla line from NVIDIA enabled, and we also have the Xeon Phi co-processors that we integrate. This is done in various flavors. So this is, I guess all of you have seen that, and there will be another presentation today, so I will not extend too much. By the way, Vladimir, am I doing fine on time? Am I doing fine on time? 15 minutes more. Sorry?
15 minutes.
15 minutes, okay. And so we integrate the latest Tesla technologies in our hardware. This is being done through a collaboration with NVIDIA, and we can have quite a bit of advanced developments. So we know that if you want to generate a project or to have a kind of proof of concept, we have created in EMEA, so that's for the territory in Europe, a lab that you can access. So for Intel, we have created an HP Intel HPC Center of Excellence, in which we can host you, once again, or you send it remotely, your request for porting or testing of Intel, whatever latest technology. So permanently, we have the latest technologies. I was discussing with a partner yesterday who told me, I cannot get access to Xeon Phi. I don't have Xeon Phi at home. So come on, I have a rack full of Xeon Phi that is waiting for you. Just contact HP and we will put you in contact with the HPC Center of Excellence that HP and Intel have created. And you can come and it's free and it's just for you to use. We have the same environment with NVIDIA. So we have an HP NVIDIA GPU Technical Computing Center of Excellence. We permanently upgrade the hardware that is available, so you would be able to get access to the latest Tesla boards in this Center of Excellence, plus the expertise to do your code porting, code tuning, CUDA porting, right? So that's available, and we have that available in our facilities that are in Europe. So just call on us, and we can help you. So that's the Intel Xeon Phi ecosystem. Some of you have experience with Xeon Phi. No experience of Xeon Phi, you have tested it? Sorry? Oh, right. Okay. So we are seeing many customers that are moving to Xeon Phi, mostly because of the, well, lesser effort to port. There's no porting on the principle. You can run your application as it is. But it is even more important to know that very soon Xeon Phi will be bootable. Okay, so that's one other thing that you may consider, is that in the future, Xeon Phi being bootable, you can think of your software application in a new fashion. And now we obviously have announced the support for all those accelerators on our SL250 and SL270. Again, SL250 supports up to 3 accelerators. SL270 supports up to 8 accelerators in a single enclosure. Okay, both Xeon Phi and Tesla. So this is our software tool that allows you to monitor the system and to manage it properly. So this is called the Cluster Management Utility. It has been sold to thousands of servers and it is being run very successfully. So we now have integrated also things like Moonshot. So Moonshot can be integrated in such an environment. What does it provide in terms of features? It provides the provisioning of nodes, it provides the monitoring, and it provides the control. What we say is that with this tool, if you have hundreds or thousands of nodes, the provisioning is done in minutes. Right? So there's no need for you to take care of the provisioning if you want to upgrade all your systems, apply patches, whatever. CMU is the right tool for you. And obviously we have a partnership, and I'm happy to see that Adaptive is in the room. We have a very nice partnership with Adaptive, where we have created the links between Goa and CMU. So that's all integrated now, and I guess you will have a presentation today, will you? Yes, you will have a presentation today, and maybe you will describe what this integration is. So that's a very nice setup that we have. So now we'll integrate the features that Moab is providing, or that Adaptive is providing more globally, and CMU. So that's also part of the value add that we provide. To finish my talk, just wanted to give you some examples of things that we are implementing and some of the capabilities. So this is one academic example in the US. It is quite huge. It is based on the SL250. So if you remember, SL250 is the 3 accelerators version of our servers. And it has up to 1 Intel Xeon Phi in each box. Okay? And if you look at the teraflop count, it's close to a petaflop, okay, 943 impact Rmax, and that's within a half megawatt envelope, which is pretty good if you look at the figures that we usually do. So that's a brand new system which has been provided. So this is now up and running. But let me come to another type of system, and that's a system which is based in Japan. It is also based on our SL. So that's the are aware, there is a top 500 and there's a green top 500. So this is the #1 system which is not experimental. This is a production system, and it is the greenest system on the planet that runs with HP. So that's the Tokyo Institute of Technology, for those of you who are familiar, Tokyo Institute of Technology. Obviously, we have references also in Europe, and I just mentioned before that we have a large contract ongoing with Airbus. That's also why I was interested meeting with some, well, local aerospace customers. I think we will have a meeting with Antonov definitely to describe what is there. But it is interesting to know the way that Airbus looks at their hardware and IT services. What Airbus is saying, he says to us, my job is not to run computers. My job is to design aircrafts. You, HP, you provide me HPC as a service. I do not want to hear about operating systems, about data center, about cost of energy. What I will ask to you, HP, is you provide me the HPC energy, I call that the HPC energy that I am using. I give it to my engineers. But you provide me everything. So you provide me the data center, you provide me the IT, you provide the management, you provide the operations, so we have staff which is running there. And in some cases we provide licenses management, because licenses for these people is a very big cost. We also provide energy, so that means that HP buys the energy from the local power supplier and resells it to Airbus. And what does Airbus do? They consume the HPC energy that is provided by HP, and in exchange, they pay a monthly rental. Can you imagine this type of setup? That also changes the way that you look at HPC today. You are a consumer, as a user, you are a consumer of an HPC energy which is provided by someone else, by the external company. It is a kind of service provider. We are the service provider of an HPC energy. Okay? And every year we have reviews, technical reviews with Airbus, and they state, hey, we would like to have a little bit more of that, a little bit less of that. Could we have this latest technology? Is there a possibility to put that in? So we do that with a lot of dialogue. But the basic principle is very clear. They say our job is not to run IT. That's someone else's job. If HP wants to do that, you're fine. So we just won the new contract with Airbus. These are images of the old. It is 3,200 servers in Toulouse and another 900 servers in Hamburg. The new system will be even bigger. So there will be 4,000 servers in Toulouse and there will be 1,200 servers in Hamburg. So let's give you the scale of what we have to manage. 4,000 servers and 1,200, so that's 5,200 servers that Airbus needs to manufacture or to create their aircraft. Okay, it is pretty amazing when you see the scale at which things are running. This by far will be the biggest manufacturing HPC site of the planet. Way bigger than Boeing. Boeing does not have the same size of systems. And that's, by the way, mostly in pods. I told you that it is run in pods. The way why we run that in pods is that, again, Airbus does not want to see the systems in their offices. So what we have thought of would be to put the pods at the edge of the Airbus factory. So that means that we have put our pods really on a parking lot which was just outside Airbus. Okay, so we are running those pods, it's HP that runs that, and we simply have the fibers, the network that goes to HP, and where they're consuming the HPC energy. Very interesting concept. So this is a new system which we are putting in, which is using our Apollo rack. If you remember, I mentioned about Apollo, the extremely high dense solutions. So they are running now these systems starting from now. The system is being accepted. So it's going to be the densest system that exists on the planet per square meter. The densest system that exists on the planet for the time being. So this is something that is being delivered, and it is very interestingly run by the National Renewable Energy Labs in the US. So they are focusing on sparing energy. So what they are doing is that they are using the hot water which comes out from another old system that is using cold water. So the outlet water from this old system is providing the inlet water for this new system. Because if you remember, I told you that this system is using warm water. Okay? So that's very interesting in terms of power efficiencies, because you don't have to chill the water. You can use normal water at air temperature or even up to 35 degrees Celsius. So that's really innovation at HB. So I hope I was interesting and not too boring. I hope my English was fine. Yet again, my intention was to demonstrate that HP is a leader, that we know how to deliver fast, that we also have the capacity to deliver better. We have plenty of products currently that help us solve the problems of our customers, and we deliver it in a smart way, right? So we have the capacities at engineering and factory to deliver many of them. With that, I'm done. I thank you very much, and if there is any question, I can take them. Thank you. Questions? Here's one.
First of all, thank you very much for your very interesting presentation. And my question, do you know any information about HP computing system which are used for weather forecast?
So,
in which countries?
So the question is whether we have HP systems that are being used for weather forecast. Of course, we do have weather forecast systems which are using HP. In weather forecast, I must say that the debate is very often whether you want to go for specialized system or whether you want to go for traditional x86 or accelerated technologies. In some cases, weather institutions prefer to go for specialized, so still vector-based systems, and there are still some vector users around. However, most of the weather organizations are now going to x86 and maybe sometimes accelerators. So we have references now which are going. We just won a contract in the US recently for the Army weather system. We just have now won a system in Saudi for their weather system. And believe me, a weather system in Saudi is really important. And we also have won recently another system in Serbia. We are working on quite a number of opportunities right now, including new systems in Spain and another system in Norway.
Thank you.
No problem.
So the question is, what are the key peculiarities of the cartridge that is used for Monte Carlo simulations in banking or finance institutions? Thanks.
So the question will be quite easy to answer. It just relies on a specific CPU that is using the specificities of Monte Carlo, which is well, no parallelism. So it is quite a trivial problem. If you want to go for Monte Carlo situation for FSI, we have a specific design that was done with one specific hardware vendor, CPU vendor, that is perfectly adapted to FSI and to Monte Carlo simulations. So I can come back with the details to you. After my talk, I can give you the details of the cartridge itself and what it is.
So the question is, how does it differ, for example, from the cartridge that is used for energy differences? What are the key peculiarities of the type of process?
No parallelism in Intel. Right? So that's very simple, straightforward. Yeah.
Thanks.
Other questions?
Sorry if my question will not have correctly, but if we see top 10 of supercomputers, we see from IBM, Cray, but Hewlett Packard only 21, yeah?
That's very true.
Okay, can you compare and say some word about it?
Yes, I can obviously compare, because what we are very proud of at HP is that we do not want to build specifically built systems. We want to be generic. So that means that we focus not on the first half of the top 500, we focus on the second half. Our capacity at HP is not to deliver the largest system on where obviously the competition is losing quite a bit of money. We want to be replicatable. We want to implement many systems and in a profitable fashion. So that is why you do not see us in the top 10. And we have no intention to be in the top 10. To us, this is a game that is reserved for people like Onstad. That's really for IBM in the US and in Europe, for Intel now in China, that they want to build. And in Europe, we see Bull that is playing this game, plus Cray sometimes. But we have no intention. Our work is really to deliver day-to-day many systems profitably. So that's why we don't focus on those high-end systems. That's too specialized. Yep, one question here. Olivia? Yep, in front.
What can you say about Platinum of titanium process?
About titanium? So we're going to... obviously there has been a lot of feud and discussions about titanium. What I can tell you is that you will need to talk to someone who is using titanium or providing titanium at HP. What I can say is that as far as I'm concerned, titanium does not play in high-performance computing. It is not the platform that we want to go after. However, what I can tell you is that many customers are continuing to use titanium today. And we see, especially in banking environments where you need high reliability, customers continuing to purchase titanium. So this is something which is still ongoing. The good thing is that titanium and the BCS product line are now integrated into HP servers. So that means that there is no distinction anymore between titanium and the rest of the HP servers. It is all one division now. But it doesn't play in HPC, right? So we do not see customers that want to run titanium for HPC. And it would be a nonsense to run titanium on HPC.
Also, good. Questions? Okay. I have also a question. Do we have weather forecast systems running Cosmo code?
Of course we do have weather systems running Cosmo. That refers to your question. Obviously, we do have weather systems running Cosmo.
No more questions.
Great, many thanks. My pleasure, and I will be staying here if you want to have private chats. Don't hesitate. Thank you so much.
Thank you very much.